Dart is a programming language that is developed by Google. It is used to build mobile, desktop, server-side, and web applications, which can run on multiple platforms. In addition, Dart is an object-oriented programming language, which means it's class-based. There is a garbage collector, and it uses the C-style syntax. We can compile the Dart programming language into a native code, or we can also compile it to a JavaScript code. It also supports many of the object-oriented programming language perks such as interfaces, mixins, abstract class, generics, and types. As of 2020, the current version of the Dart programming language is version 2.7, which we can find at dart.dev website. As we learn the Dart programming language, there are some important facts and concepts that we need to consider. So one of the most important concepts is that in Dart, assuming that we have a programming language background, everything that we place in a variable is an object, and every object is an instance of a class. So this means that if we store a number in a variable, that number will be an instance of a class. Even a variable with no value has a value called null, and that null value is an instance of a class or an object. Every object inherits from the object class, the base object class. So there's a class called object in Dart. Dart is also a strongly typed programming language, but Dart can also infer types. This means that if we want our type to be specific, we can use a specific type, or we can use an inferred type. This means that in the future time when it's compiled, Dart will figure out what the value type is. Dart programming language also supports generic types. There are also top-level functions and functions that are tied with the class or an object. This means that, for example, the main function is a top-level function, but anything that is within a class is tied with that specific class type. In Dart, there's no keywords such as public, private, or protected, unlike Java, but we have a way to make a specific method or top-level function or property or variables private by using or specifying an underscore at the beginning of the variable or the method or the function name, so that that specific variable that is starting with an underscore name can be private to that specific library. In addition to that, identifiers can start with an underscore name or any letters followed by a number, a letter, or an underscore. The Dart programming language reports two types of problems. The first one is warning, and the second one is an error. A warning is an indication that there's a problem in your code, but it's not going to stop you from compiling it. On the other hand, the error will throw a runtime exception or a compile time exception. The Dart programming also has keywords that we cannot use as a variable name, as shown in here. Some of the keywords might not be, supported yet, but most of them are. In Dart programming language, variables store references to objects. That is, a variable is a spot in the memory or a container that contains some references to some values. The Dart programming language have several types, such as an integer, strings, booleans, floating point numbers, and so on. We will look at each one of them one by one. Here I have a Dart file. I'm going to create my main function so we can look at each variable types or built-in Dart types. So first let me create the main function. So let's first use the integer type. In Dart, we can create an integer variable using the int data type or the integer or the int class. The default implementation of an integer data type in Dart is a 64-bit signed integer. That means an integer can represent a negative and positive number. So since it is also a class, there are some properties and methods available to manipulate the data values. In order to create an integer, we use the int data type name, then we can provide it the name of the variable. So let's see, I put the number 5,000 here, and we can print it, my int As you can see, it prints the result. We can also apply some of its properties, which are actually defined in the documentation. So my int, for example, if I wanted to check if this integer is assigned, or the sign of this integer, sign, give me the value 1. The reason is because if the number is 0, give me the result 0. But since the number is greater than 0, it give me the value 1. That means this number is positive. If the number is negative, I'll get the result -1, as you can see. And we can also check if this number is an odd or even number by using the property is odd. And this number is not odd. And so on. There are also some methods. For example, the absolute value of this number can be obtained by using the following method, which is 5,000. And I can also convert the integer to a string by doing toString function, .toString. Now I have a string and I'm able to print it. And for full reference, we can check the documentation. The double class or the double data type is used to create a double precision floating point number. Dart double data type is a 64-bit floating point number. If we do an operation on a double, it always returns a double. So to create a variable of type double, we can use the double keyword, and let's say my double, and we can provide it a value 45454545, like that. We can also print it. And just like any data type, a double is a class, so there are properties and members available for it. For example, we can check its sign, my double dot sign, which is a positive number. We can even use the function to round this floating point number. We can round it to 45. So rounding it to an integer. So what is returned in here is an integer. We can also check the runtime type to see what is returned. So you can see when we round it, we get an integer. We can even convert this to a string and print the string. We can also use the truncate method to discard the digits. As you can see, the digit is truncated and it returns an integer. But we can also do operations on the double type, such as addition, subtraction, multiplication, and this is going to return a double. For example, if I have an integer here, my int, and it has the value 599, if I do an operation on this integer, that is my double plus my int, or let's take it out of the print statement here, and let's create a var result, and we add my double in my int, and what I want to look into is the return type. So result runtime type is going to be double, since adding it to a double. As you can see, it's the double. So any operation done on double is always going to return a double, and so on. So this way we can create a double data type, and for full reference of its properties and methods, we can reference the Dart documentation. The other data type in Dart is the Boolean data type, which is bool. This is also a class in Dart. So every time we create a Boolean variable, it is a class instance or it's an object. So this data type is reserved to store the true and false object. So to create a Boolean data type, we can use the bool and my bool, and I can put true or false here. Just like any other data type, there are methods and members available in the bool class. I can convert this, print this variable to a string by doing toString, and I can even get the hash number for this hash code by using the following property. And we can also even check if this data type is a Boolean or not by using the runtime type, and it will tell me that this data type is a Boolean data type. For full reference, we can check the documentation as well. A string is one of the many data types that we use to represent text in Dart. A string in Dart is a sequence of UTF-16 code units. That means a single character may be represented by multiple code points, each code point consisting of 1 or 2 code points or code unit. And also a string can be either a single or multi-line. So let's create a string variable in Dart. We start with this string data type name and give it a variable name, my string. Then I can say this is Dart string, or I can also use a double quotation my string to create this is Dart string and double quote. And this is called a single line string, but I can also create multi-line string by doing the following: string my string 3. I have to do the opening of my quotation using 3 single quotes. Then I can say this is Dart multi-line string value, which is written for testing, and we can continue. But again, this is a multi-line string. We can also do the same thing for a multi-line string using double quotations by string my string 4 by specifying the double quotation 3 times. So 1, 2, 3. Then I can come here and let me copy this part. Copy, paste, new line, paste, new line, paste. Then I can finish the multi-line string like that, and we can print it. For example, if I want to print my string 4, as you can see, I get the multi-line string printed in my command line. As we said, a string is a data type, and any data type in Dart is an object. That means it is instantiated from a class. So any class will have a property and a method, properties and methods. So a string has a lot of rich sets of properties and methods to manipulate its members. For example, for more reference, we can go to the Dart documentation, but we're not going to look into all of them, but let's look at some of them. For example, if I use my string, if I try to print my string length, this is one of the properties. So it will tell me how many characters that I have in this string. I can also use the my string code unit at position 0. So it will give me the decimal Unicode value for the first character, which is T in my string. So if I try to print this, so this is not saved, I get the number 84. Or I can even print for all the characters and it will return a list. I can also get the hash code if I want. So if we copy this, paste it here, and then call the hash code property, and we can get the hash code for the string. And we can also use methods such as compare to. So if I want to compare this string to my string 2 and see if they match or not, as you can see, they don't match, so it's -1. If they match, I'll get the value 0. If one of the string is bigger than the other one, I'll get the value a positive number. And I can also use if my string ends with a specific substring, so ends with, and let's see, it ends with the string. So see the result. As you can see, it returns true because my string ends with the string. I can also pick a substring from my string. So we can do substring, and let's say I want to start from index position 6 up to index position 12. We know the length of this string is 19, so this will give me from index position 6 to 12. So let's save it and see. As you can see, it gave me from here up to here. I can also use another property called contains. So contains, and I can give it the substring name Dart, and see if my string contains Dart, and as you can see, it's true, and so on. And for full reference, we can check the documentation. If we are not interested to explicitly annotate our variable types, there are 3 different ways that we can create our variables. So the first one is the var keyword. The var keyword is used if we want to create a data type, but we don't care to annotate its type. For example, I can say var my number, and I can assign it the number 6, or I can do var my float 5.6. Either ways, we can use the var keyword in case in the future we are interested to change the value to an explicit data type. On the other hand, there is a keyword called dynamic. Dynamic is used to underline all Dart objects. So we can create a dynamic data type by saying dynamic and my num1, my num, say 6, and dynamic my str. So mostly the Dart programming language will use the dynamic keyword if our data type is not initialized. In this case, if I have a variable var my str2 and this variable is not initialized, so now this annotation is changed to dynamic at compile time. So it's always a good idea to use the var keyword instead of the dynamic keyword if the variables are initialized. The other data type, or this one is a class, is the num data type. Num is a class which is used to create an integer or a floating point number. So if I'm not interested to explicitly state the data type, I can call it num and I can assign it either a floating point number or an integer. For example, my float equals 4.66. Since this is already used, let me make it my float 2, and I can do my int 2 like that. Since num is a class, we have few properties and methods that come with this class to operate on the data type, such as converting a given value to an explicit data type. For example, if I want to convert my float 2 to a double my float 3, I can do my float 2 dot to double, and this number will be converted to a double data type. Or I can do int my int 3 equals my int 2 dot to int, then I can convert it to an integer. As you can see, it compiles without any problem. And for a full reference, we can check the Dart documentation for the num class. So now let's talk about functions in Dart. We say Dart is an object-oriented programming language. So even functions are objects, and this means that they have a class type called functions. So let's create a very simple function and try to invoke a function. So I'm going to create a function that returns nothing, which is void, and I'm going to call it my first fun, and this function is going to print first function, and we can invoke it by calling the function my first fun, and if I compile it, I get first function. My function can also take a parameter, so I can put here, let's say, a string param, and I can also print it as part of the string, and I can come down here and give it a value. The name of the value is input, and as you can see, we are able to use the parameter too. A function can also return a value. Instead of printing it over here, I can return a string, and we have to change the return type to string, and over here I will store the value to a variable result, then I can print the result. Dart programming language also have two kinds of function parameters. They are called positional and named parameters. So let's look at them one by one. So the one that we are familiar with is the positional parameter. If you have a programming background, especially in Java or C++, positional parameters, just like any parameter, for example, here I have my first parameter name, and the second one, for example, age, And the third one is going to be, for example, again int year. Then I can be able to print this parameters or return the value of these parameters. So what I can do is name is going to be name, and age is going to be age, and year is going to be year. Then in the output, positional parameter requires us, so let's change the name of the function to position param. So positional parameter requires us to define the value of the parameter corresponding to their position. For example, name has to be, let's say I have Dart, that's the name parameter, and for age, let's say 10 years, and let's say it's developed in 2000. So that means that they have to correspond to their position. If, for example, if I move the name at the end here instead of at the beginning, I will end up getting an error because the first parameter has to be a string. So that's the purpose of positional parameter. So if I try to print this, I'll get the right result. Also, we can use a named parameter. Named parameters are introduced with Dart. So for example, if I have a string return type for name, named param, and I have to put them inside a curly brace, and I'm going to use the same parameter's name. So this way also I'm going to print or return the same result. So what this means is that for positional parameter, I can define the name in any order, either at the beginning or at the end, as long as it is a positional parameter. So let's look how we could do that. So we have var and res2. I'm going to call named. Then I have to specify name and provide it with Dart. And I have to specify age and provide it with, let's say, year. And I have to specify year and provide it with 3000. Print res2, and if we print this, we get the result. So now if I move or define age first and name last, as long as I have it as a key value pair, I will not have any issue. I get the correct result. So if I print it again, as you can see, name is always Dart. But this doesn't mean that we can discard the keyword when we initialize our parameters. So they have to be in the form of key value pair. The other way to define parameters is making the value of a parameter default. So this means, for example, I'll create a function here, default param. So I'm going to use the same parameters value. So here I'm going to make the last parameter, which is the year, to have a default value, that is 1999. And now let me print it. So what this means is that I have optional parameters, no, positional parameters with a default parameter. So one of the parameter is optional, that we don't need to provide a value since it has its default value. Anyone who invoked this function can use the default value unless we want to change the value. For example, if I try to use this function, let me copy this and change this to result number 3, and we can change, let me call the function here. So I'm gonna call the default parameter. So as you can see, Dart is telling me that I need to define a value for these two parameters. For the first one is going to be Dart, and the second one is going to be, let's say, 30. Now if I try to print this, I get 19. Oh, I'm printing result 2 here, has to be result 3. So I'm printing 1999 for year. But if I want my own value here defined, I have to use the named parameter syntax. That is, year has to be, for example, 4000. And if we try to print it, as you can see, now it's not using the default parameters, but the value that I specified for it. There's also an optional parameter syntax where we can define an optional parameter for our functions. So let me create a function, string, and let's call it optional param. And it will take a string, which is name, a default, an integer, age. I mean, it's a positional parameter. But optional parameters can be encapsulated with a square bracket. So int year is optional. If we don't want to define or initialize or provide a value for year, it's okay. The function will still be invoked. So now if I try to print this, return a string first with the value of each parameter. Then I'm going to copy this and I will try to invoke the optional parameter function. So let's call this variable number 4 and this one number 4, and we will change this to optional param. As you can see, I do need to define name and age because they are positional parameters, and let's give it the age to be 9, or 9 has to be a number. Then now if I try to print it, as you can see, year is null. The reason is because we know that if you don't provide a value to a specific variable, Dart by default will assign it null, and we didn't specify a value for a year parameter here. So I'm gonna say, let's say 1988, and we save that. And if I try to print it now, since I defined or provided a value, I can see the year to be 1988. So this are some of the way that we can define parameter for our function. Like any other object-oriented programming language, we can also create our own type in Dart using the class keyword, and we can instantiate an object for our own type. This means that there are classes and objects. So we can create our own object or class type using the class keyword. So let's create a very simple class or a car class. So I'm going to use the class key, and by convention, a class name has to start with the capital letter car. Then any class will have its own class member or property. So for example, my car class can have the year the car object is made, year, and string model, what kind of car it is, and let's say it's whether it's new or let's say it's status, whether it's new or old. Then we can define we can use the default constructors to instantiate this car object. So for example, if I go here and try to create a car object, I can do car, my car, and I can use the new keyword to create the car object, or I can ignore the new keyword because it's redundant, and by default I will have a default constructor created for me every time I create a class. And also it's important to know that any object is a child of the object class. So this car can use some of the object class methods, or it inherits some of the object class methods, so I can be able to invoke them or use them with any class that I instantiate. For example, if I try to print the hash code for this object, I can call my car dash hash code. As you can see, I didn't define any property or method called hash code in here, but this hash code is coming from the object class. You can reference the documentation, and this will give me its own hash code. I can also define my own constructor, but before we define our own constructor, by default we also have a getter and setter methods defined for our class members. This means that I can use my car and access each members. For example, year, I can assign it a value, for example 1988, and my car model, I can assign it, for example, I can say Ford, and the status, my car dot status, old or new. Let's say it's old, so it's not running anymore. You can say false. So I'm able to use the getter and setter method that are defined by default, or by default with the class. So I'm able to assign them a value, set them a value. But I can also, create my own getter and setter method. We'll see that. But first, let's look at how we can actually create our own constructor. To create a constructor, we have to use the car name. We don't need to define a return type, so a constructor doesn't return anything. Then we have to provide it with some parameters. For example, I wanted to instantiate the class members with values while I am creating my class object. So I will define a year here, model, and status. And then I can come here and say this, so that this keyword refers to the current object that we are accessing. The current object is the current object that is being created. It's referring to this class, the current object. So this year is going to be initialized with the year parameter, and this model with model, and this status was status parameter. So this way I created my own constructor. So that means that over here I have to define, it's no longer, using the default constructor. So it has to use this constructor that I defined for it. For that means, so I need to define a value for it when I create my object. So this way we can also shorten this syntax by doing this year, this model, and this status. Now this syntax is clean and almost that's exactly the same as the previous syntax that we used. In addition to that, we can create our own methods. Methods are functions, but they are part of a class. So for example, I can create print car properties method, print the year and the model and status. So now I can invoke this method in here by using the mycar.print car property. So if I try to run it, I get the result. And instead of creating a function like print car properties, I can also override the toString method that is inherited from the object class. So I can change this to a string and override the toString method. So if I override a string or a method from its parent class, I have to annotate it with the override annotation. So now I can, instead of printing it, I can return it. Copy this. So I don't need to use this method anymore. And this has to return the string. That way when I try to print my car object, this method will be invoked. So this is done by doing print my car. Now it automatically invoke this function. So let's run it. So I forgot to put a semicolon here. As you can see, it printed the data or the result of each values of each properties. We can also define a named constructor for our class. We can use named constructors to implement multiple constructors for our class and to provide extra clarity for what our object is creating. So we can do that by, for example, if I want to create a car object that only initializes the year it is made, I can do car year made named constructor that takes in the year. Now when I try to create my car object, my car2, I can use the named constructor by doing year made, let's say 2005. Now if I try to invoke or try to print the values of each members, my car2, I will only get the result for, or a value for the year. So let's print it. As you can see, the other two members are null. This means that we can create multiple named constructor for model made, desktop model, and we can do status made this dot status. We can also define a getter and setter method for our class. In this case, we know that there is a default getter and setter method defined for any class that we create, but we can also define our own. For example, if I want to define a getter method for the year property, I can do, say it's an integer, and get, so we do get year, and this will return year. Since it's a very simple or a single line function, I can use the fat arrow like that, and I can return the year. So the benefit of having a getter or setter method is that we can have our own, for example, I can have my own condition here that checks if, for example, year equals null, then I will return a default value, for example 1999, else I will return year. And similarly, I can define a setter method for my year property. We can do that by doing set year, and it takes in an int value of a year, and we can use the fat arrow here and assign year with s year. Or we can also check if year is not null, or we can, for example, if s year is less than 2000, then what we can do is set year to be 2000, and we can return. Even though we're not returning anything, we're stopping the function from continuing the execution. But if that's not the case, then we can assign year with s year. So this way we can come up here and let's say I have my car that uses the named constructor, assign a value to it. So if I come here and try to set my car to with the set year equals 1999 and save that, and if I try to invoke my getter method, I have to do get year, and I will run it. And as you can see, it's 2000 because 1999 is less than 2000. But if I say, for example, set it to null, and if I try to get the year, as you can see, I get an error because null is not a value. So that means we will never reach this. Or what we can do is, instead of invoking null here, I can give it null in the named constructor. Now if I try to use the year getter method, I'll get 1999 because if I try to set it to null, the get year method will check if it is null or not. If it is null, it will return 1999. So that's one of the benefits of using getter and setter methods instead of using the default getter and setter method. In addition to that, we can create our own method. And then, for example, I can create a string method and car live, and this will return, for example, the year it was made. So what we can do is we can provide it the current year and current year, and we can current year minus the year it was made, so it returns a string, an integer, I mean. So we can create our own method for our class, and we can also use some of the function perks such as the positional parameter, default parameter, named parameters, just the way we used when we looked into how we can create function video, and we can also apply those perks in here or in class. One of the key feature of object-oriented programming is extending classes. You extend class to create another class and extend the property from the parent class to a child class. So they have names. For the parent class, it is called base class, while the child class that is extending the parent class is called derived class. And this property is known as inheritance. We can only do a single inheritance in Dart. There's no multiple inheritance, but we can do multi-level inheritance. So let's look into that by creating our base class first. So let's create an animal class animal, and we have a member called name. This member has a default value, and we have a default constructor, base class, and let's give it one named constructor, my base class. So base class named constructor, and we can print the member value name. So I'm going to do void print member name, and an animal can have a method that called move. So print animal is walking. So this is my base class, basic animal constructor with the name animal, and two constructors, one named, one default constructor, and a method that prints the name, and a method that says animal is walking. Then one of the animal can be a class of dog. We know a dog is an animal, so we can extend the animal class and inherits some of its properties and methods. So a dog constructor can change, so I can override the constructor dog, and I can also invoke the base class or the animal class constructor by using the key super. This way both the animal and the dog constructor will be invoked. The first one to be invoked is the animal constructor, and I'll print. So what did we say here? So I'm going to say dog class constructor, and I can also provide it with the named constructor. So say dog dot, let me use the same name, my dog class, and I can also invoke the animal class named constructor by doing super dot my base class, and this is going to print dog class named constructor. So this way we are able to invoke the dog class constructor and the extended animal class named constructor. And if I want to change the value of some of the members or methods that I inherited from the base class, for example, I have a print member class here. I can override it by using the override annotation. And first let me define the function void print member. So we need to provide the override annotation here because we know this method already exists in my base class dog name, this dot name. I can also override the walk method or the move method, void move print dog is walking, and I have to annotate it with the override annotation. Now we fully extended our dog class with animal class. Let's create a dog object here. This will invoke the default dog constructor. Then I'll change the name of the dog to, for example, let's call it Dart. And let me see the name of the dog, print member, and let's make the dog walk, and let's run this. As you can see, first step, when I create the constructor, base class constructor is called, then the dog class constructor, then the name is modified to Dart, then the dog is walking member or method is called. Similarly, I can even invoke the named constructor here by creating another dog, var dog2. So I'm going to use dog dot my dog class. So, and then let's see what is being invoked first. As you can see, the base class named constructor is invoked, then the dog class named constructor is invoked. So this way we inherit some properties from the base class and avoid, duplicating codes by using the inherit object-oriented programming style. We looked at how inheritance work in Dart. Now let's look at how polymorphism work in Dart. So I'm going to create a class, same animal class, and this animal class will have a member string name. We will call it animal, and it has a default constructor animal that prints constructor, animal constructor. Then we will have a print member method, and lastly we will have a move method. So this also has to be move print walking, and this is also void. It's important to provide return type. So now I'm going to create two classes. First one is going to be a dog class. The second one is going to be cow class. So a dog class can have a name constructor, string name dog. It can also have, a name member and a name. Then we can also have a dog constructor, default constructor, dog, and this will be print dog constructor. Let's change this to life is started. So instead of having a default constructor for every class, we can call the superclass constructor and do nothing here. And we can override the print member name, and we have to annotate it with the override annotation. We can do the same thing for the cow class. Name is going to be cow, and we can have a default constructor that invokes the superclass constructor, because life is going to start for every animal the first time we instantiate the object. Then we can also invoke the print or override the print member with its own member name. And now we can create our object. So let's create a dog object. I'm going to use animal 1. That's going to be animal 1. And this animal is going to be a dog. So the reason dog is not assigned to an animal class is because it's not extending the animal class, or it's not inheriting the animal class. And we have to do the same thing for the cow class. Now I created a dog and assigned it to an animal class, and I will create another animal here, 2, that is a cow. Now if I try to invoke the animal class, print name, let's see what we're going to get. As you can see, I get the dog name, and if I try to invoke the second animal member name, I get the cow name. But in both cases, the super or the parent constructor is called, and their both will be calling the same. For example, if I want my animal 1 to walk, I will call the move function, and animal 2 also needs to walk. As you can see, they are invoking the move method from the parent class, which is animal class, but they are invoking the correct print member class from the overridden print member class in each dog and animal class. So this is called polymorphism, where we call our objects take different form when a parent class reference is used. There is an important concept called mixin in Dart. It is a way of reusing any class code in multiple class hierarchies. So let's see how we can use mixin in Dart. I'm going to use the animal class as a base class, and then we'll have a name, string name, animal, and we'll have a constructor that prints print animal construct, and it will show the name of the object. So print name, this dot name. So but let us create another class called a class dog. So the dog class will extend from the animal class, and the only thing that we're going to have is a string name dog, and we will have a constructor dog, and that's going to call the super constructor, but it doesn't do anything to its constructor, and it will use the superclass or the extended or inherited print name function. Let's check it. So I'm going to create an animal object of dog, and dog.name, print name should give us the name of the dog. Alright, but what I wanted to use is the mixin class. To use the mixin class, first the purpose of a mixin class is to reuse an existing class. For example, let's say I have a class here called a cat, but it doesn't extend the animal class. But it has a, let's say it has a void, a run method, and this run method will say the animal is running with its 4 legs. We know that dogs also run with their 4 legs, so as animal, so as cat. So I wanted to use this class. Instead of duplicating this method in the dog class, I can use the Mixin concept to reuse this code from the cat class. I can do this by specifying the following syntax with cat. So it extends the animal class, but it reusing the cat class properties and method. This means that if I go up and try to call dog.run method, I should be able to run it. But the reason why I'm seeing an error here is because I'm creating an animal object from a dog class. So if I change this to dog, since the Mixin is in the dog class, I will be able to access the run method from the cat class. So if I run this, I will get the animal is running statement printed on the terminal. So the purpose of using Mixin is just like I stated at the beginning, is to reuse an existing code and to avoid duplicating existing code. An abstract class is used to provide a partial class implementation. There are 2 key points to look into when we write an abstract class. That is, we cannot instantiate an abstract class, or we cannot create an object from an abstract class, and we cannot declare an abstract method outside of an abstract class. So let's look into how we can use an abstract class in Dart. To create an abstract class, we need to use the keyword abstract, then provide the name of the class. For example, if I wanted to create a remote control class, a remote controller, I can provide it with some functionalities such as increase the volume and decrease the volume. And we also need to provide it with a property. So that is int volume. As you can see, the 2 methods in this abstract class are not implemented. They are defined but not implemented. As we stated at the beginning, we cannot instantiate an abstract class. If I try to do a remote control or a remote control that is instantiating or creating an object of remote control, is not going to work because this is an abstract class. In order to use this abstract class, we have to extend it to a concrete class so that this methods can be implemented. For example, if I create a class of a TV remote controller, and if I extend the remote controller class, this means that I will be forced to implement the 2 methods, or I will be forced to override the 2 methods. So in Visual Studio Code, I can click on the name of the class and I will see what I need to do. By clicking create or over the 2 missing overrides, I can create 2 methods. So for example, I can say print decrease volume, and I will also say print increase volume, or I can also do volume plus plus, volume minus minus. Since volume is null, I need to initialize it to 0 first, or I can also do it in here by saying 0, give it initial value. Now I'm forced to implement the 2 methods and able to use the abstract class. I can also come here and create an object for TV controller, TV, and TV controller. Now I can call TV.decrease volume or TV.increase volume. Then I can print TV.volume. Let's comment this out and see the result. As you can see, we get the result -1 as expected. And I can also apply the same abstract class to other classes that requires the use of increase and decrease methods. So the purpose of abstract class is so that we can summarize the main idea of the class that we are creating. So in abstract class, as we saw, we can share or use normal properties and methods. I can even create a normal method here, void info, and I can print it by saying this is a remote controller class. And as you can see, I'm not required to implement this method because it's not abstract, but I can still use it, info. And I can also, add other methods in my concrete class by saying TV info and print. And this is a TV info class. Sorry, a TV remote controller info class. And I can use this normal class in here again. TV info, like that. Now let's look at interfaces. Sometimes we need to reference variables and methods of many classes at the same time. We can use Mixin for this case, but interface comes in handy. An interface is used to provide a contract that says all the derived classes should be followed. And when a class implements an interface, it implicitly defines all the instance members of the implemented interface. We can simply understand this by looking at a small example. But some important concept to consider here is that an interface doesn't have any special key or keyword that is applied or added on a class to consider it an interface. So we can create a normal class. For example, let me create an food ordering class, and that food ordering class have some common behaviors like taking order from customers and updating your customers that the order is done, and accepting payment. So let's create a class that is called order, and we will do take order method here. Then we will do update order over here, and we will have a void accept payment behavior. So now our class is taking or implementing the following behaviors or method order, and let's print here updating order, and over here we can print accepting order. Now let me create another class that is class pizza order, and this class definitely needs to implement all the methods defined in the order class. So we implement the order class here, which is going to force us to define all the methods and implement them, as you can see, even though they are already implemented in the order class. But since this is an interface for the pizza order class, the order class is an interface for the pizza order class, we are forced to implement them. So I will do print pizza order accept payment, and I will update the order is ready. And now I am able to implement my pizza order class, and I was taking the structure of the order class. This means that if I have a class that provides service, it's a requirement to have this behaviors implemented in that class. So it's a contract that I need to fulfill whenever I have a business that takes order. So that's what it means in here. Also, we can split the payment method to a different class, saying class payment, and this class will have accept payment method. So I have my methods inserted here in the payment class, and now since I need to override my accept payment method, or I needed an accept payment method, since this is a business that accept payment, I can also implement this interface payment. So that means I'm able to implement multiple interfaces to my single class. So here, the difference between abstract class and an interface is that we can implement more than one interface to our class, but we can only extend one class or one abstract class. And an abstract class forces its unimplemented method to be implemented and overridden, while an interface forces all its method to be implemented by any class that is implementing it or extending it. And the other important point is that we don't really have to have an implementation for our interfaces. We can leave them blank and we can implement it on the class that is implementing it. As you can see, all the classes, all the methods are not defined but not with an empty body, but they are implemented at the pizza order class. So I can call pizza, or I can use order, I think, and I can call pizza order, and I can order dot take order, and then see what the result is going to be. As you can see, pizza order takes order. So this is how we use interface in Dart. In order to create class-wide variables and methods, we need to use the static keyword. The advantage of using a static variable or method is to consume less memory. That is, if we have an instance variable or method, once it is instantiated, it consumes memory whether it's being used or not. So how do we create a static variable or a static method? For that, I'll create a simple class of a rectangle. Or let's do a circle. So I want to use the pi variable. So I can have a static variable called pi 3.14, and the static variable is constant, so I have to use the const key. I don't need to specify the value of the type. Then I can create a constructor. Well, first let me have one instance variable, int radius, and let me give it a default value, which is 0, and a constructor that takes this radius and initialize it. And I'm going to have a static function that computes the area of a circle, static, and let's call it double area, and it takes in the radius and returns pi times radius. I guess that's the formula. Then now, if I create an object for this class, circle C, or let's call it circle, and instantiate it with the value 4, I can't use the circle object to access the area class because it's a static class. To do that, I have to use the circle class, the name of the class, dot area, and I have to obtain or get the radius of my object by using the circle dot radius, and compute the result and store it to a variable and print this result. As you can see, I get the correct result. So that means if I create another circle here, 2, with a different radius, I'm still required to use var res2, the circle class, to access the area method, and I have to provide it with 2.radius, and I have to print the result for print res2. As you can see, I get the result. If I want to access, for example, the pi value, I also need to use the circle class name first, dot pi, since it's a static variable, and that way I was able to access the static variable. So that's how we use static variables, or that's how we create static variables and static methods in Dart. Access modifiers in Dart is different from the one we know in Java and C++. This means that Dart doesn't support the public, protected, or private keywords in class. Instead, we can use the underscore at the start of the name of the data member or a function or a method to make them private or only accessible to that specific class. To demonstrate this, the first thing that we need to do is to create a new file. Let's say I want to have the following mymath.dart file. Inside this file, I'm going to create a class type mymath, and I will have two, let's say, properties. The first one is going to be num1, and the second one going to be num2. So we haven't looked at on how to actually use or create our own libraries, but to use the following library, simple library, we can import it to our main.dart file by doing import and the name of the class, which is mymath.dart. Now we can be able to access the mymath class, mymath. I'm going to create an object of mymath, and I'm able to access the two properties num1 and num2, m.num2. Since we said there's no protected, private, or public keyword in Dart, the only way we can make this fields or properties private is by putting or adding the underscored character before the variable or the function name. Now, if I go back to my main.dart file, as you can see, it is telling me that the num2 is not defined in my class because it's private. It's only accessible from or within the library or within this file. We can do the same thing for a method. For example, if I have an add function that takes in or that adds the two properties and returns the result. So this is done by this num1 plus this num_num2. Now if I go to my main.dart file and if I do add, I'm able to access the addition function. And if I compile this, even though it says it's null, so we can fix this by creating a constructor. So we can do mymath and this dot and this dot, and now save this. Our object will take two values. Now if I compile this, I'm not gonna get any error. So if I want to make my function only accessible within this class or private, all I have to do is just add an underscore. Now if I go back to my main function, it is telling me that it's not defined. So what if I add the underscore add after it? Still it's telling me that this function is not defined. And the same thing for the underscore num2. So we can make our methods or properties private by preceding the property name or the method name with an underscore. Similarly, we can do the same thing for a function that is not defined within a class. So say I have an integer that subtracts two numbers, a and b, and returns a minus b. So if I want to access the subtract function that is defined in the mymath class, I can do so without any problem. But if I make it accessible only within this library, or if I want to make it accessible only within this library, I can precede the function name with an underscore. Now this function is visible only within this class, but outside of this class we can't see it. If I go back to my main.dart, I see that this is not defined. Maybe because we didn't put the underscore in here. Let's do that. Again, even after putting the underscore, still this class is not defined. It's telling that this class is not defined in my math.dart library. So this is how we can use access modifier. And the Dart programming language has some unique features that are not seen in other programming languages. So we will look at them one by one. So the first one is the string interpolation feature, which we have actually used in our previous videos. But for example, let's create a variable myVar, which has the value 5. If I want to concatenate or print the value of this variable in a string, what I need to do is to print the value using the string interpolation, that is $sign and the variable name. This way we can be able to see the value instead of the name of the variable. So that is dart main.dart, and as you can see, we can see the value. We can also print expressions such as add, and for this I need to use the curly brace, so I can surround part of the statement that need to be evaluated. So 6 plus 5, for example, will be evaluated and the result will be printed. We can also call a method. For example, if I want to use one of the string method so I can capitalize a specific word, I'll say caps, then I'll open the curly brace and close the curly brace. Then I will use name, that's the string. I need the string to be in double quotation, name. Then I want to apply the uppercase function to upper. If I run it, this string will be capitalized. So this way we can use the string interpolation method within a string. The next unique feature is the null aware operator. For example, let's create an integer variable here, my int. Then if I wanted to check if this integer variable is null, all I need to do is to use the null aware variable, and if it is null, I can assign it a value. We know that if a variable is not assigned a value, by default it's null. So we can check that by doing a print statement, and we can save this and print it. As you can see, it's null. Then in this case, what I need to do is, if I can assign it a value, but if I want to assign this value only if it is null, I will use the following syntax. I'm going to do 2 question marks, and for example, I want to assign it the value 7. So what this statement is saying, that assign it a value if it is null. That's what it means. So for example, if I print this, I get the value 7. But if the integer is already initialized with a number or any value, let's say I have the number 9 is assigned to this integer variable. Again, what this statement is going to do is it will check if this integer is null or not. If it is not null, it's not going to change the value, or it's not going to assign the new value. So we can check that by printing this statement. As you can see, the value is still 9 and the value is not changed. And that's the purpose of null aware operator. The next unique feature in Dart programming language is the conditional property access feature. This means that if I wanted to access the property of an object, the first thing that I need to do is to check whether that object is created or instantiated or not. If it is not instantiated, if it is null, then I don't need to, deal with the exception issue. Instead, a null value will be returned. Because if I try to access an object property that is not existing, I will end up with a runtime or a compile time error. So let's look into creating an object here. What I'm going to do is I'm going to create a string. A string is an object, and the string name is my string, and I will assign it a value. This is Dart language, and I can definitely access its property because this string is not null. By doing, for example, its length, I can print its length. And let's print and see. So it says 21, the length of the string. There are 21 characters in this string. But what if I define a null variable, string variable? And if I try to access the property, it might work by saying 0. But unfortunately, as you can see, I'm getting an exception, unhandled exception, because the string is null, and I'm trying to get the property of this string, which is already null. But if I don't want this exception to happen, what I can do is I can change my syntax by adding the question mark after the variable name or before the dot point. And this way, now, if I try to print this statement, I will not get the unhandled exception issue. So let's print it. As you can see, it's returning null because the string is null and it doesn't have any value in it. So I can't use the length property in this string object. So in a simple sense, this means, if we want to understand what exactly this means, is without using the question mark, it means that I am checking whether the string is null or not. If it is null, return null. If it is not, apply that property on the string. So this means that my string is checked if it is equal to null or not. Then if it is not null, then I can apply this statement by getting the length of the string. But if it is equal to null, I will return null. That's what it means. So if I print this statement, second statement, again I get the same result. So null is printed twice. The next unique feature is on collection literals. So we've seen how we can actually create collections in Dart. There are three types of built-in or Dart supported collection: list, which we can call an array, maps, and sets. So creating a collection is very easy in Dart. So I can give it a name and call it my list. And to create a list, all I have to do is just open a square bracket and provide it the values. And if I want to create a set, all I have to do is just use a curly brace. So a list is an array and a set is an unordered set of elements, and they have to be unique. That means each element has to be unique. And the last set is maps, my map. And to create a map, we have to have key pair values. So we'll have a key and a value, a key and a value, like that. So this is the easiest way of creating an initialized list. I can also create a list by doing the following: my list 2, and define its type. So its type for my list is an integer, so I created an empty list. I can also create sets and define its type, and I can also create a map, and I can also define its key pair value types. That is done by doing a string and an int, like that. So this is one unique feature in Dart. So the next one is a simple unique feature that we looked in our previous tutorials. For example, let's say I have a function that returns a string, and retstr is the name of the function, and this function only returns one line. This is Dart language. So as you can see, this is a very simple function. So to put this in one line, we can use the arrow syntax, or what is known as a fat arrow syntax. That is done by stripping the return name and replacing it with a fat arrow syntax, and closing the statement. So this is a very simple function that I can call just the way I call other functions. Since it's returning a string, I have to print it. The next unique feature in Dart is cascades. So a cascade is a way to perform sequence of operations on the same objects. So this can be done on objects. So first I need to create a class. So to create a class, let me clean this first. Here I'm gonna create a car class, and a car class will have few properties. For example, an integer year, the year was made, and an integer a string, the name of the car. Then it will take a constructor car, and it will initialize this two properties or attributes, year and this dot name. Then I will have another named parameter that only initialize the year attribute, made year, and this dot year. And I will create a method that just says drive, and it prints driving the car. Then now I will come here and demonstrate how to use the cascade syntax. So the first thing that we need to do is to create the class object, and I can do that by doing car, my car equals, the year is going to be 2000, for example, and the name is going to be Honda. Then I can go to the next line, and I can change the year if I want by saying year equals, oh, I was wrong, so I'm gonna make it 1999. Then I can call the drive method, and I can complete my short syntax in creating object, modifying the year, and calling the drive method from the car object, my car object. This is almost the same as doing creating a car, my car. So for example, I'm going to create a second car object, car, let's say it's going to be 2000, and again it's going to be Honda, and I'm going to use my car 2, and I'm going to modify the year 2001. Then I'm going to use my car 2 to call the method. So the above syntax is simpler and smaller than the bottom syntax. That's cascade. That's how we use the cascades method syntax. So if I run this main function, I get the result. How do we provide an argument to our main function? As you can see, our main function has a parameter that is an array of strings. So if I want to provide an argument to be passed to the main function so we can process that our argument values, we have to manipulate or access it by using its index position. So first, let's look what our argument is holding here. I'm going to print the argument variable args. It has to be encapsulated within a double quotation or a single quotation. So let's save this and let's look at the result. As you can see, it's an empty array or list. But if I want to provide an argument to my function, I can say, for example, 4 here, then a space, dart, which is a name. So my list now contains 2 elements, 4 and dart. So if I want to access each element specifically, I can use the index position. So for example, index position 0 is my first element, which is 4. So if I run this, I get 4. If I put index position 1, it's gonna print dart. So this way we can use the argument variable or the argument parameter in our main function. So if we have a standalone program, that way the user can provide the an argument to our program, and then we can manipulate that value within our program. In this video, we will talk about anonymous functions. In Dart, everything is an object, as we stated many times in our previous videos. A function is also an object. This means we can store a function in a variable so that we can use it anywhere in our application. So the advantage of having an anonymous function is that we can declare anonymous functions without a function name. We can also assign it to a variable. Anonymous function can be passed into another function. We can use them as a parameter for another function. But one small disadvantage of using an anonymous function is that an anonymous function cannot be used recursively as it has no name. So let's create an anonymous function and see how we can use it. To create an anonymous function, we create a function without a name. So then we, for example, we can print this function to say anonymous function. Then since it's anonymous and it's an object, we can assign it to a variable. And then if it is the longest version of anonymous function, we need to give it a closing statement, which is a semicolon. So this is our simple anonymous function, and we can call it just like any other functions in our main function, my anonymous function. Then if I run it, main.dart, I can see the output. We can also simplify it to its simplest syntax by using the fat arrow thing here, or the fat arrow syntax like that. And over here we close the statement. And if you compile it, you get the same result. We can also use an anonymous function inside a class. For example, let me close this, let me delete this, and let's create a class. Let's call it math, my math class. Then this math class will have an addition function. So this means I need to take two parameters or inputs, int a and int b. Then I'm gonna return the result, a plus b. And we stated that anonymous functions or functions in general are objects. So we know that there is a base class called function, which is found in the documentation, as you can see here. We can use that function type to assign it to a specific function type. So for example, if I create a function and let's say add, and now I have an anonymous function object stored in a function type called add, then I can come up here and create an object for my math class. Then I can call that function add, then provide it, for example, 3 and 4, and store the result to a var called res, and then I can print this result. If I run this, I get the value 7. The benefit of creating anonymous functions comes in handy when we use higher order functions. A higher order function is takes or accepts a function as a parameter. They can not only take a function as a parameter, they can also return functions. So let's look at a simple example on how to use or how to create a higher order function. So first, I'm gonna need to create a function. So this function is going to be an addition function, add numbers. And this function we will create an anonymous function inside this function. And this function is going to be called add, this anonymous function. Then it takes in int a and int b, and it will return a plus b. And we will return this function, return add. As you can see, this function returns a function. Then I can come up in my main function. I will use this function var result add numbers. Then I can print the result res. But result, since it is a function that is returned by an add number function, it takes into arguments. Then now if I print it, I get the result 9. This means, or the advantage of using or returning a function is that we can store functions and variables or reference, and on later time we can refer back to those function or that function by name. So having a variable contain a function object gives us freedom to pass it around our application like any variables. The next concept that we're going to look into is closure, which is tied with anonymous function. Before we do that, let's look into lexical scoping. For that, let me create a simple example and understand what lexical scoping means. Let me create a variable here, a var, or let me create a variable at the top here, var, and I'll say outside. This is our global var, and I will say this variable is global. Then inside my function, I will try to access this global variable and I will try to print it, which means that I'm able to access this variable. But let's create a function inside this main function that returns a string inside main. That's the function name. And inside this function, I will create another variable, a var, inside main var. And I will say this variable is inside main function. And I'm definitely going to specify where I am, which is inside invoking inside main function. And I'm also able to access this variable so I can print it inside main var. So far I'm not getting any error because I'm able to access all the variables without any problem. I can also print the function that I created inside the main function as well, inside main. And let me run it. As you can see, I'm able to invoke the global variable. I'm able to print the global variable, invoke the inside main function, and able to print the variable value inside the inside main function. What if I try to access the inside main variable outside of the function? So let me try to print inside main var here. As you can see, I'm not able to access it because inside main var, lexical scoping is within this function. Outside this function, we cannot access it. So that is called lexical scoping. That means the scope of a variable is within this function. Once we pass this block, we're not able to access it. So now we understand what lexical scoping is. Now let's look into closure. A closure is a special function that has access to the parent scope even after the scope is closed. This is because since it wraps any non-local variables that was valid at the time of declaration, it actually closes over the variables. Let's look at this concept through example. Let me first create a variable, and I'm gonna say this is a string, and I will give it a name, my string, and I will say this is I guess this is a global variable, and I will create anonymous function, and I will give it a name, my function, my fun, and it's not going to take any argument, but it will have a local variable called string, my string, and assign it a value. This is inside my fun function, and I will print the result, my string, and I'll close this statement. Now I'll come to my main function and I'll try to print the result of my string. When I print the result of my string, I'll get the following result. But when I try to call my fun function, the result I'm going to get is what I have inside my local function. This means that the anonymous function closure is overriding the parent scope. So if I come here and try to print it, I get the following result. Or to make it more clear, we can also create another anonymous function called function, and my second fun, and this function will create anonymous function and return that function when my second fun is invoked. So let's create function, and I'm going to call it inside my second fun, and it will have a variable, local variable called my string, and I say this is inside my second fun, just give it the number 2, and I will print this result, my string, and I will close my statement. So now I have a function that is anonymous, and that function will create a function and returns this function inside return inside fun. Then I'm going to invoke this function in my main function. Let's delete this part or comment them out for now. But before that, I'm going to create a variable of my string, and I will call it this is created inside my main fun. And now I'll see if this string or this variable is going to change when I invoke my second fun. So my second fun returns a function. So I'm going to store it inside result variable, and I'm going to invoke my second fun. Then I'll print the result of, since it's returning a function, the result is going to be invoked. And if we try to run this, we get this is inside my second function. This means that the return result from the function object is able to access the variable in its lexical scope. This means that because Dart is a lexically scoped language, the innermost scope is searched first. We can also apply higher order functions and closures inside a class. So let's look at a very simple example by creating a class called myMath. First, I'm going to create anonymous function, or it's also called lambda. So function, and it's an add function, and it takes in an int a, int b, and it returns a plus b, and we close the statement. So that is a lambda expression or anonymous function. Then now I will also demonstrate how to use the fat arrow in anonymous function. That is, let's say this function will return the value of pi, and I'll say pi, and I'm gonna define the value of pi down here. I'm gonna make it static, pi, and I'm going to say 3.14 final, and I'm going to take it as a value, int pi, and the return value is going to be pi. Then I'm going to create a higher order function that accepts a function as an argument, and it returns the result. So I'm going to do int compute add, and this function will take in function myFun, and it takes in two values, a and b, int b, and what it does is it will print the result of myFun to a and b. This is a higher order function. Then I will have a closure by doing the same thing that we did when we learned about closure. So that means, let's say I want to print string, and this closure is going to return a function. No, let me call it my string. This is inside a closure function, and this is printed. Close the function, and it returns this function inside, not invoke, return. And we need to have a myString property or field or variable. I'll say property of the myMath class. Now we can create an object of this myMath class, and we can invoke the functions. So let's start with our lambda function. We can print add 4 and 6, which is going to give us 10. But unfortunately, since this is inside a class, we have to invoke it by using our class name. And this should give us a 10. I can also access my higher order function by printing the result myMath.compute, and this will take a function myMath.add, and the results, let's say 7 and 8. Close it, save it, and I should see 10 and 15. And if I want to access my pi, I can use myMath.pi value, and this will take myMath.pi, or since it's a static variable, we have to use the class name. So since this is a double, we have to change this to double. As you can see, I get the result 3.14. I can also access my instance variable, but let's see, we can print our instance variable by my class and my string. See, I see the result. And I can also access my closure, which is print myMath dot, the name is print string function. Since it's a closure function, we have to store it to a variable first, since it's returning a function, anonymous function. Var res is going to take this, and res is going to be invoked. As you can see, this is inside a closure. That means my string instant variable did not modify the result of my closure. So this way we're able to use anonymous function or all the other anonymous type functions in a class. In this video, we will talk about Dart's data structures and collections. Data structures helps us to organize information for storage and later retrieval. Using the built-in collection classes in Dart is a big advantage because they allow us to manipulate lists of data, and they allow us to access the collections of data in a type-safe manner. There are 4 types of data structure in Dart: list, set, map, and queue. We will look at each one of them one by one. Let's start with the list data structure. A list is a simple ordered groups of objects, and if we come from, or if we have another programming language background, for example in Java, a list is an array list, or in C++ term it's an array. There are 2 types of list: fixed length list and growable list. In a fixed length list, the length of the list cannot change at runtime. However, in a growable list, the lengths can change at runtime. So let's look at an example here. To create a list, first we need to use the list class, which is list. And this way we created a growable list. We need to give it a variable reference, var my list, and we need to close the statement. Then if I want to store a collection of data, I can use one of its properties, since anything in Dart is an object, so a list has properties and methods. I will use one of its method called add. So I'm going to use my list dot add, and I'm going to add the number, for example 5, and I'm going to add more numbers, 8, my list dot add, let's say 4. If I want to print it, I can say print and provided the name of the list. Since it has a toString method, it will print the collection, as you can see. Or I can also create a fixed size list. This is done by using the list keyword, list. For example, if I want them to be a collection of integer, I can use the generic type int, then I provided a name, my fixed list, then list provided the fixed size, for example 4 elements only. So in order to add the elements, I have to use their index position. So that is done by using my fixed list name. Then index position 0 will be what? Say 6. My fixed list index position 1 will be 5. My fixed index position 2 will be 1. And we will leave the last index position null. So if I try to print this, my fixed list, as you can see, the last index position is not filled, it's null. I can also use different way of accessing the value or looping through the value of my list. One way is to use the for loop this way. So I'll do for, I will provide it a name for each list type, for example var, let's say I, in my list, which is my fixed list. So every time my list is going through the elements one by one, it will store the value in variable I, and I will be able to print the result just like this. So if I run this, I get 6, 5, 1 and now one by one. I can also use a higher order or anonymous function to print my list. That is done by using the iterator function for each. So I'm going to use my fixed list, in this case dot for each, and I'm going to provide it a function. This function is a higher order function that is going to apply the following functionality in each element, or apply the following code in each element. For example, if I want them to be printed, all I have to do is just call the print function on it, and each element will be accessed through the following variable or parameter for this anonymous function. For example, I can give it the name element, then my print function will access each element one by one and will print them to the terminal. I have to enclose it in a double quotation. Now if I save this, and let's put this in here, save it and run it, as you can see I was able to access each element. I can also use the old school for loop syntax for var I equals 0, and I has to be less than the length of the list, that is fixed, my fixed dot length, then I plus plus, and then I print old school for loop, and I'm going to print the value of I. That is done by doing this. Then I can run it. I have to save it. Fortunately, I have an error, so here I have additional syntax error. As you can see, I'm able to access each element using the old school for loop syntax. These are some of the ways that we can be able to print the content in my collection, my list collection. I can also apply the following looping or iteration styles in my growable list as well. We can also apply some of the list class methods on the list collections. For example, I can use my list. If I print this list, I will get 3 elements. But if I want to, for example, I want to remove the first element, I can do print my list dot remove at index position, for example 0, and I will end up with 2 elements. So index position 0 is removed and printed. But if I come here and try to print my list, as you can see, I only have 2 elements left. I can also use the clear method to clear all the elements from the list. As you can see, all the elements are deleted. I can also create a list and initialize it right away. That is done by opening a square bracket, for example. And for example, I want to add a number here. Now, if I print this, I get the list. If I want to check whether this is a list type or not, I can do dot runtime type, and check what its type is. As you can see, it's a list of integers. I can also pick, for example, the first 3 elements by using the following method, take. So the first, let's say 4 elements, and return them as a list. So if I run this, I get the first 4 elements. I can also skip the last, print my list that skip the last 3 elements or 2 elements and return the rest of them as a list. As you can see, the first 2 elements, sorry. The first 2 elements are skipped and the remaining elements are returned as a list. We can also check if my list contains specific value by using the contain method. My list that contains, for example, element number 6. If it does, it will print true, and so on. So for full reference of list class methods and properties, we can check the Dart documentation. The next data structure is the set data structure, and Dart is an ordered collection of unique items. This means a set represents a collection of objects that can occur in the list only once. To create a collection of sets, we can use the following syntax. Set, for example, collection of strings, and let's say names or programming language. And I have to use the curly brace and specify each programming language. For example, C, Java, and Dart. So if I print this, I get following result. For example, if I add Dart or C twice, I'm not going to be able to see the duplicate item. So as you can see, I can only print a unique item from the list. I can also create a set from a list by doing the following. For example, let me copy this and paste it here. Then let me say this is programming language 2. Then I'm going to make this a list by putting a square bracket. But if I want a set from this list, I use the function from, set.from a list. And now if I try to print this, I get the same result. Print prog2. I can also create an empty set, then add the elements runtime by doing the following. Set int and my set. And now I can add my set at runtime. Only one element. And we can print this. We can also use the same looping syntax that we looked into our list example in our set example. For example, if I want to print all the elements in my programming language or the following sets variable, I can do for, let's say, var I in prog lang, then print them one by one. As you can see, I'm able to print them one by one. You can also use the old for loop syntax, or we can apply the for each syntax on a higher order function, such as prog lang, and we can use for each. Then it takes in a function. The function has a parameter, let's say it's my element. Then this function will return a print element. Then I can print them as well. I can also use some of its methods, such as, for example, does my programming language contains, for example, a C element that is true, as you can see down here. Or we can use prog lang is my list, or sorry, my set is empty property. So you can see it's false. Or we can remove specific element from the list, that is prog lang dot remove. Say let's remove C, and let's print prog again, prog lang. As you can see, C is removed from the list, and so on. We can check the documentation for full reference regarding sets, properties, and methods. The next data structure is a map. A map is a key value pair data structure. It is an unordered collection of key value pairs. The advantage of using a map is that the key value pairs can be any types. So let's look at an example here. First, let's create a map. To create a map, we use the map type and specify the key value pairs. For example, I want the key to be a string and the value to be an integer. And I'll say grades, and I'm going to create my map. Now I will say my grade to pass, which is a key, will be 50. Grade to fail, let's say, is 0 for now. Grades to get perfect grade, we will say 100. Now I can access the grade pass by using its key. As you can see, I gave 50. I can also use a for loop or an iterator to access each values or keys as follows. For let's say var I and grade dot. I only want to access all the keys. Then I can print all the keys as follows. I can also access the values by changing this to values, as you can see in the terminal. I can also use a higher order function or a for each method, grade dot for each. Then I'll create an anonymous function, and this anonymous function has two parameters, the keys and the values. Let's call it key. Then I can print key, and the value. I need to put this in a double quotation. Then I need to close this. Now I can print both the keys and values together, and I can also check some of the methods that are available with the map class, such as print. Let's say my grade contains the key pass. It does. This will be true, and we can do the same thing for value. We can also create a map and initialize it right away as follows. For example, I want to create a map that takes two integers as a key and value, and my map, so I can initialize all the values in here. So the first one is going to be, let's say, 0. The second one, the key has to be a string. The key has to be an integer, as we said. 1 contains 0, and 2 contains 50, and 3 will contain 100. Now I can print my map. As you can see, I'm able to see the key value pairs as follows. So to summarize, a map key has to be unique, and we can have multiple values, and a map is mostly known as hash or a dictionary in other programming languages. And as we saw, the size of a map is not fixed. For example, I can add a new value to my map by doing, for example, 5. Now let's say 4 is going to be what? Oh, I have to do this outside. 4 to be 100, and since the size is not fixed, this will be part of this map. If I print it now, I have additional element, and we also have a hash map, which we can refer the documentation, which is also an implementation of a map, and it is based on hash table. So for a full reference, we can also go to dart.dev and check the available properties and methods for a map class. A queue is another data structure that is useful when we are trying to build a collection that can be added from one end and deleted from another end. In order to use the queue data structure, we have to import Dart class. To import a Dart class, we use the keyword import and specify Dart and the class name. In this case, since we are using a data structure from the collection class or library, we use Dart collections. Then we can create our queue object by doing queue. Let's call it queue and call a constructor. To add an element to our queue collection, we can do queue.add, and let's say I want to add a name of a programming language, Dart, and queue. I can add more information, for example, the year. Let's say Dart is 10 years old. Then I can add more, 10 years old, and Dart is multiple platform programming language. Now I have my elements. So if I want to print this element to the terminal, I can use the for var q and print q. As you can see, I'm able to print all the elements. I can also use the for each function too, q.forEach, and we can provide our anonymous function print I, or let's say element, and the element has to be provided to as a parameter for my anonymous function, and I'm able to print it as well. We can also use some of its methods. We say that a queue adds an element from one end and remove it from the other end. So I can do queue.remove first element and print queue. As you can see, the first element, which is Dart, is removed here. Or we can also use the queue.remove last, and we can print queue, and then we will be left with 10, the value 10. We can also access a specific element by providing its index position. For example, print q dot element at index position, let's say 0. Since we only have one element left in this case, we'll get the number 10. This way we can be able to use the Q data structure in our Dart programming language. For full reference, we can check the documentation. In this video, we will look into how we can use generic in Dart. Generic programming is a style of computer programming in which a specific algorithm are written in terms of types to be specified in later time, that is, a compile time. For example, I want to create an addition function that takes in a floating point number and returns a floating point number. So the only way I can do that in non-generic way is by specifying the type and the name of the function, and I provide the two parameters, double let's say a and double b, and I will add the two functions and return them. So a plus b, and this way we can compute var ret double a and b 4 and 5. As you can see, since we need to provide double, we have to specify 4.5 and 4.3. The name of the function is odd. But if I wanted to create a function for example, an integer, then I have to specify the type to be an int in each case, and then I can return another function that duplicates the code but only computes addition for an integer type. Even though this can be solved in Dart by using inferred types. For example, I can use var a and var b, return a plus b. This way I can either use a double or an integer, because Dart can infer its type. But we can also have another way where we can use a generic type and a compile time type can be specified by the user. So this can be done by using the following syntax. So let's assume we have a function that returns type t. T is by convention is used as a generic type, and it takes in two parameters, type t a and type t b, and returns a plus b. Inside here we need to specify what type t is. Type t, in this case, since we are doing an operation, and an operation cannot be done, for example, if I use a type string, that type string cannot operate on the plus sign, so we need to use a num type which can either be a number, an integer, or a double. So in this case I can extend the num type, so num is either an integer or a double. Then this way I have a generic function that returns the results of two num types added, or the addition of two num types. So this types can be either an integer or a floating point numbers. So if I, for example, as you can see, I'm not seeing any error at this point of time. If I change to an integer, it works both ways. We can also apply the same generic type to a class so that our class can operate on different types. For example, let me create a class of type my math class, and it's going to be type t. And again, this let's constrain this class to work on an integer or a floating point number by extending the num type. Then our class will have two properties. The first one is going to be a, and the second one is going to be b. And I'll have a constructor for it, my math, and it will take this dot a and this dot b. Then I will have one method that return type t, and let's call that method add, and we'll add the two properties and returns the result, this dot a plus this dot b. We can also add subtraction method, t sub, we can subtract, return this dot a from this dot b. Now I can create an object here of my math, and my math class will be type, let's say double, and m is the name of the object, and my math, since we have a constructor that takes in 2 arguments, the first one is going to be 4.5 and the second one is 6.7. Now I can call the addition function on this math object, and I can store the results to a variable, and I can print it. This way we were able to see the basic syntax of using a generic type in Dart. In this video we will look at how we can use Dart core libraries and community package. The Dart programming language has a built-in essential multi-platform libraries. We can find this list in the documentation as shown in this link. As you can see, we have many different libraries that are compatible with different systems. For example, we can look at the math library, which provide all math functions. If we want to import or use this library, all we have to do is just use the import keyword and define Dart followed by colon and the library name. In this case, for example, the math library. Then I can do, for example, get the pi property or constant here. For that, I can do pi, print pi. As you can see, I get the pi result. Or I can even use the square root function, which is defined in the math library. Square root of 4. As you can see, I get 2. Similarly, we can import the Dart input-output library, which is defined in here. The input-output library can provide us many functionalities. The simplest one is handling file read and write. So I can use the same example in here and manipulate write to a file, read to a file, from a file, and so on. Similarly, we can use a community contributed package or package that are developed by other people by going to pub.dev website. Here we can be able to use the Dart package by downloading the package from the link. So for example, let's look for the HTTP package. The HTTP package doesn't exist in the core library, so we can import this package from here. In order to do that, or we have to configure a file so that we can be able to get or download community package. So this is done by first creating a pub spec YAML file to manage the package in our project. Then we have to give the name of our and then a name for our project in our pub spec YAML file by using the name property. And I'll call the name to be what? Learn Dart. There are other properties that we can define, but name is key. If name property is not defined, it's not going to work. Then we can also define the environment, whether we want this package to be for a specific version of SDK. I'm not going to define this, so I'm going to skip it. Then we can use the dependency property to define our package. For example, I'm defining the HTTP. I'm downloading or getting the HTTP package, HTTP. Then I define the specific version, or I can leave this sign or character so that it can grab the most recent version. As you can see, the name field must be valid. I'm not sure what's missing here. Probably I need to do that. So I can't use a dash here. I have to use underscore. And I have to leave it blank so it can get the most recent version. As you can see, the HTTP package is downloaded, including its dependencies. Now I can use the HTTP package in my project by importing HTTP. So if we downloaded external package or a community package, we have to use the package name, HTTP, and the package file name. And I can shorten this package name by doing as HTTP or even H, but I'll do HTTP. I think it's already HTTP, so I don't need to do that. So now I'm able to use the HTTP package. For example, I can do a get request var result, and we can do a wait. Since it's a get request and a network request, we need a wait. Then we do HTTP dot get, and let's say I want HTTPS www.google.com. Let's ignore the error field for now and just print the result. Since we are using the asynchronous code, we have to make our main function async. Since HTTP is not a valid object or class, let's say I'm going to use HTTP here. I'm going to give the name of the package HTTP, shorten the package name. Now I'm able to access it. So if I go to my terminal, CLS, and run Dart. So I didn't get any response, but at least I'm able to use the package. So this is just to demonstrate how to use external package in Dart.